Welcome to qnawire.
So in this question, the ethyl alcohol, that is C2H5OH gas, is burned in a steady flow adiabatic combustion chamber with 90% excess air. The adiabatic flame temperature of the products is to be determined, and the adiabatic flame temperature as a function of the present percent excess air is to be plotted here. So when we analyze the question, the complete combustion reaction in this case can be written as C2H5OH, which is gas, plus 1 plus AO2 plus 3.76 N2 gives, I'm writing it down, the product I'm writing it down, 2CO2 plus 3H2O plus O2 plus FN2. So this is the complete combustion reaction in this case. Now, we go slowly. Okay, let's move down. Now, where the eighth is, what is this ATH given? Is this stoichiometric coefficient of air? Okay. Now, the oxygen balance gives the oxygen balance that we are talking about gives 1 plus excess of 8 into 2 is equals to 2 into 2 plus 3 plus 1 plus XAF into 2. Now, the reaction equation with products in the equilibrium is, we are going to write down the reaction equation with products in equilibrium. So it goes C2H5OH gas plus 1 plus 8O2 plus 3.76 N2 gives you, I'm writing the product with green color, ACO2, we are giving the variable here. Then we'll balance it. Okay, so when we see this, we understand now we are going to, the coefficients are determined by the mass balance. So that is what we are going to look here. So the carbon balance is equals to 2 is equals to A plus B. Now hydrogen balance, 6 is equals to 2D, that gives you D equals to 3. Now the oxygen balance, 1 plus EXA into 2 equals to 2A plus B plus D plus 2E. And the nitrogen balance is 1 plus EX into 3.76 is equals to F. So these are the mass balances that we have got. Now, solving the above equation, we find the coefficients to be Ex is equals to 0.9, 8 is equals to 3, A equals to 2, B equals to 0.00008644, D is equals to 3, E equals to 2.7, and F equals to 21.43. Now we can, in the above equation, we can just write it using this equation. The total moles, not writing the equation again. So the total moles of the product okay. So the total that is N total. We will put it as N total. That is N total equals to 2 plus 0.00008644 plus 3 plus 2.7 plus 21.43, and that is 29.13. Now the assumed equilibrium reaction can be written as CO2 CO plus 0.502. Now the Kp value that we have. So the Kp value of a reaction at a specified temperature can be written or can be determined from the Gibbs function data using the equation Kp equals to e raised to minus delta G star T upon RUT, or log Kp is equals to minus delta G star into T upon RUT, where we can understand that delta G star T is equals to VCO G star bar CO, temperature of the product, plus VO2 G star bar O2, temperature of the product, minus VCO2 G star CO2 T of the product. So this is G star. So the Gibbs function are defined as G star CO T of product equals to H dash minus, H dash minus T of product CO G star O2 T product is equals to H dash minus T of product S dash O2 G star CO2 T of product is equals to H bar minus T product S bar CO2. Now the equilibrium constant is also given by the equation Kp equals to Be 0.5 upon A upon P upon N total, and that is 0.10008644 into 2.7 raised to 0.5 upon 2 into 1 upon 29.13 raised to 0.5, which is equals to 0. I'll just write it down, which is equal to 0.00001316. So this is the Kp that we got. Now, this is the Kp that we have got. So we got this value of the Kp here. Now a steady flow of the energy, if we see, gives the balance. If there is a steady flow of energy, then there is a balance, that is HR equals to the HP, that is the product, and the reactant. So in this case, HR equals to F fuel at 25 degrees Celsius, 5.7 H-O2 at 25 degrees Celsius plus 21.34 H N2 at 25 degrees Celsius, which we get the value to be minus 235,310 kilojoule per mole plus 5.7 into 0 plus 21.43 into 0, which gives us a value of HR to be equals to minus 235,310 kilojoule per kilomole. So this is the HR. Now when we take the same thing for the product, that is 2H-CO2 at the temperature of product plus B into H-COT at T product. Temperature of the product I'm writing again. 3H-H2O at T product plus 2.7 H bar at O2 at T product plus 21.43 H bar N2 at T product. So this is the HP. Solving the energy balance equation using the EES, the flame temperature for the product, that is the T product, is found to be 1569 Kelvin. So this is what is our answer. I hope you understood this question.